Hey guys, welcome back. So, in this video, we're going to go over how to rewire a classic car. So here we have a 62 Volkswagen Beetle. I believe these are 6 volt when they were manufactured, but this one's 12 volt. But like a lot of classic cars, there's some original parts, there's some replacement parts, some aftermarket parts, and we're going to show you how to rewire the whole thing. So step 1 is essentially remove all the old stuff, which I'm not going to show on video, but just imagine all the original electrical coming out of the car. And then we're going to pick up with how to move forward. What do you do next? So this can be an overwhelming thing. So I'm going to show you my approach, how I go about rewiring a car to where it's not overwhelming, to where everything makes sense and there's no surprises. And let me show you how we do that. Okay. So, what you'll see here, we've got an Excel sheet. And let's just run through how we did this. Keep it simple. So, there's a lot of different things in a car. So the first thing I did was just make a list of like different things. Like headlights, you got high beam and low beam. There's running lights, there's a headlight switch, there's brake lights, turn signals. The instruments have lights themselves, which have light bulbs. There's different indicators. So this car, the gauge cluster has little LEDs. This is an aftermarket thing, but it shows you some of the stuff like that. We've got a tachometer, a voltmeter, it's got the radio. This car has a high-end stereo as well. Cigarette lighter plug, windshield wipers. This has a fuel-injected engine, but still it has a coil pack, a wideband. There's ignition switch. It has a computer that runs the engine, a fuel pump, injectors, an alternator. This car has air ride suspension, although we're not messing with that, but it does have it. Amp for the stereo speakers, as well as a separate amp for the sub. USB ports for charging phones. We got an oil cooler fan, the starter motor, and the starter solenoid. That's basically a summary of all the electrical parts that go into the car. Now what you'll see, so first thing we did was we made a list, and then we said, okay, what size wire do we need? And how long is that wire going to be? So to do the size of the wire, you kind of need to know how long it's going to be and how many amps it pulls. So what I did, see how there's a column here for amps? Let me show you. Okay, so what I did was I have this here, it's an amp meter, it's a clamp on. So if you take this amp meter, put it in DC and zero it, you can clamp this over a wire and turn the circuit on and it'll show you how many amps it pulls. Really neat. These are super handy, and I only paid like 50-60 bucks for it or something. They're not too bad. So you definitely want to have one of these. It just makes it easy so you don't have to cut wires. You can just clamp over them. And so what I did, was I have this thing called a power probe. And what I did was I hooked this to a power supply. So I'm not even using the car's wiring anymore. I just have like a, I'll show you. I have this guy. So this is a 50 amp 12 volt power supply. You can actually adjust the voltage on it as well, but I just leave it at like 13.8. There's a switch for that. But anyway, got a 12 volt power supply. I hook my power probe to it, and then I go around and hit each individual circuit. And so when I inject power, I use the power probe. You just hit a button here. You can do like positive or negative. It's not plugged in right now, but if it was, there's a little voltmeter. And so you inject power to like a headlight and see how many amps it pulls. Tail lights, blinkers, fuel pump, like you name it. Now things like a fuel pump, if the fuel system's not pressurized, you're not going to get an accurate number. So keep that in mind. If the circuit, like for example, the starter motor. I don't think I measured that one. I have measured starter motors. I have an amp meter in my Miata that'll actually, in the car, and it'll measure the starter. But anyway, I didn't do this one. But most every other circuit I did. And so that tells me what the amps are. So just in that whole approach, you might be thinking, great, but I don't want to short something out. I don't want to have a problem. So here's another thing you can do. So this is a power supply that has a current adjustment. Now this only goes to like an amp, I think. Yeah, 30 volts, 1 amp. So you got to be careful. It'll go to 30, which is too much for a 12 volt car. So I set this to like 12 or 14 volts. And then this knob here is the current adjustment, and you can adjust this. Here, I'll actually show you how this works, because I think this is plugged in. Yeah. So here's the positive and the negative. See these two wires? I'm just going to short them out and watch what happens. So they're shorted, and see how I've got a red light that says CC? That's constant current. So that means the supply is shorted. You can see the voltage drop to like almost 0, and the current is at roughly 0.5 amp. So I'm going to zoom out. maybe. Yeah. Here, I'll just show you guys. Watch what happens. I'm going to turn this knob up. See, the amps go up, amps go down. That's constant current. And then if I stop shorting the wires out, you'll see the green light. That's constant voltage. And changing the current doesn't change that. You have to change the voltage to change that. So these supplies are super handy. Like, you can turn this way down, like your constant current mode. And now when I short the wires out, see how it comes on, but it just has hardly any current? Very little current. And this has a low and a high. So right now we're in low, which is the bottom of the scale. So that's like 0.05 amps. That's like 60, 70 milliamps. Now I can switch to high if I wanted to. So it gives you the choice, which is super cool. This is great when you're doing an old car and you're like, hey, I don't want to damage anything. I don't want to accidentally short something out. This allows you to limit power. So what I would do is I would take this thing, hook my power probe to this, and then I can go poking around and say I set it for like, you know, if I set it to like 0.1 amps, well, there's not much in a car that works at 0.1 amps, maybe like an LED bulb, but short of that, nothing. But I set it to like an amp. Well, you can test some things with an amp. So anyway, pretty handy. You can test like LED bulbs, you know, little stuff, nothing big. But also the power probe I showed you, this guy. So the power probe actually has current limiting as well built in. So like if you short this out, I think it goes to like 8 amps. And if you go too many amps, then it turns off as well. Okay, so that's how we get the amps. Now that's important because if you're going to design the wiring for your car, this is one of the biggest things you have to decide is what size wires to run for each circuit. And unless you measure the amps, you're basically guessing. And so you can try to research, hey, how many amps does this pull? How many amps does that pull? But that's really not worth it. Every car could be different. Your car could be customized. It's actually not that hard to measure stuff, especially with a clamp-on amp meter. You don't have to cut any wires. You just clamp it over the wire, shoot some power into the circuit, and just see what the number is. So that's what we did. So you can see the numbers here. Now, a couple of these I did estimate, like this one. That's just a switch. Now in this particular car, this is just driving relays, and that's why I just put an amp. It's not even an amp, it's like less than that, but I just put a conservative number. But a lot of these I actually did measure. And then some of them I even bumped them up a little bit to be safe. Like the windshield wipers. These didn't pull 8 amps, but when I did a quick Google search and people said it could go up to that, so I put 8. So anyway, get yourself a list of these. You can see the starter motor, we got it down at 150. I know the one in my Miata, it pulls about 130. So it's probably close. It's going to have a big fat wire anyway, it'll be fine. So this is kind of like the main thing for me. And then what you'll see over here, so when you start wiring stuff, some things you're going to want to be key, like when you turn the key, like always hot. So this means like it has power no matter what. So, and you can see here, we got a few circuits that meet that qualification. One of them being the key switch. Well, that makes sense because if the key switch doesn't have power, how can anything else get power? Another one is the alternator and the starter motor that I didn't click. Here, starter motor. So 3 things are going to be hooked to the battery all the time. Now in our application, we're actually going to, I think we're going to fuse the alternator, I think. It's going to be a big fat fuse, but it is going to have a fuse just in case it like shorts out or something. And yeah, so those are the things that have power all the time. And you'll notice then we have a column for hot and run only, and then hot and run or start, and then hot and start only. So you can see I've got ones representing things that are, you know, which group they fall into, right? Like which one of these groups. So I just went down the list, and a lot of this is common sense. Like, so say you want your car to start. The headlights, this is a common thing. It used to be that when you go to crank the car, the headlights would turn off because you give all the electricity goes to the starter motor, and headlights can pull, like you can see here, 9 or 10 amps. So by turning those off, it gives extra juice to go to the starter. You got a better chance of the car starting, especially if you got a low battery. And then, you know, so the thinking is basically anything that's kind of like ancillary, that's not really important, shut it off when you hit the starter. So things like the radio, the windshield wipers, the cigarette lighter. Here's another group. Air ride, stereo, charging ports for a phone, an oil cooler fan, like all that stuff, who cares? Like, turn it off. You know, I didn't do the math here, but I mean, you probably save like 20 amps worth of crap that can now go to the starter, which is important if you want the car to start and you got a low battery. So then you have this one that says hot and run or start, and then there's hot and start only. So hot and start only is easy. That's basically the starter motor or the solenoid or relay that drives the starter motor. And then run and start is all the stuff that actually needs to be on in both cases. So we're going to do running lights. That's kind of like a safety deal. The headlight switch, because that runs the instruments and you need to be able to see the gauges when you're cranking the car. Brake lights, that's a big one. So you could argue that that should be always hot. Some cars are. But this car wasn't wired that way from the factory, so we're going to keep it the way it was. Also, it's compatible with, I'll show you later, I've got a device that makes this easy. Brake lights and turn lights, yep. Instruments, got to see the instruments. Obviously to run the engine, ignition, the wideband, the injectors, the computer, the fuel pump, all that stuff has to be on. So that gives us our groupings of like what stuff needs to be hot when. And this is how I go about wiring cars. So you got to figure out like the details of things before you can really know how to wire the car. And okay, so here we go, right? We got our amps, we got which wires are hot when. We can estimate the length of the wires and then the wire size. So for wire size, what I did was I just used an online calculator. So if I go into a calculator and say I got, you can see here it says 9 amps, and I've got a 16 gauge wire. So just using an online calculator, you know, that actually works out. But the thing is, this is actually driving 2 headlights, not 1. So each headlight's only getting half that. We can go down to like running lights. So when I was wiring the car, you'll notice here, there's only a few sizes of wire. There's 20 gauge, there's 16 gauge, and then I think it drops to 10 gauge. Now you can use, like, they make a bunch of different size wires. So like you could buy like a whole bunch of sizes, but it gets expensive. And so for this car, it just made sense to only use these 3 sizes as like common sizes, because I had to buy a spool of these wires. So, and then we have 8 gauge. That was required for the alternator. We're actually running dual number 8 wires off the alternator. Let's see, what else? There's a 4 gauge for the starter motor. I'm going to buy that locally. And the amps have 0 gauge, but that's already in the car. And 2 gauge, I don't have to worry about that. That's already in there. So yeah, that's how I did the wires. I could have used like 22 gauge on some stuff. I could have used 18 gauge, but I just simplified it to make it easier. Plus, it's less stuff to deal with. I thought it was a good idea. Let's see, what's next? Okay, so once we have this list, we're like, all right, now we got to start creating schematics. Now, this is how I do it. I don't like guessing. When I go to wire a car, I want to have like a diagram I can look at and just be like, okay, this wire goes here, that wire goes there. I don't have to think about it. I'd rather do the thinking first, get it documented. Then I have like a copy of like what it is. I can review it, make sure it makes sense. Then I'll do the wiring last. There's actually a thing like this in coding where they say like the last thing you do is write code. You kind of like do a bunch of other steps first. But anyway, so you can see here the first one says headlights, running lights, instrument lights, switch and relay. So here's the first schematic. I've got these in order as they appear in there. There's like a stack of these. And here's the first one. Now it's just on paper. These aren't digital. I'm going to take pictures of them and make digital copies, but I just do this stuff by pencil and paper. You can do it however you want, but this is what I do. So here, this car has like a floorboard switch for the headlights. That's here. It has one of those pull switches that you do like off, running, and then headlights. That's this switch. And then when you twist it, it changes the brightness of the instruments. That's this wire. And you'll see the way I did these, like if we zoom in a little bit, like here's headlight switch. So this is like a label. This actually comes from the fuse panel. These are, I'll show you that in a little bit. And then you can see it's like a red wire and it's a number 20 and it goes here. This is the back view of that switch. So I might have it here. I don't see it. But anyway, I drew this the way it really looks on the car. These are the positions, which makes, when you go to wire the car, this makes it easier. This is kind of like the difference between a diagram and a schematic. This is still kind of a schematic, but diagrams are kind of like the way it really is. And this helps you, like I did draw this the way it really is, so when I go to wire it, I already know like, oh, there's a flat here, this one, this one, this one, this one, and they're labeled. And you'll see every wire has a call out for the color of the wire and the size of the wire. So that just makes it easy when you go to wire the car up. And then things like relays, Same thing. I just kind of draw it to where it makes sense. You see the coil, you see the normally open and normally closed contacts. You can see here, like we use this contact is normally closed, and then when you energize the coil, it flips and touches the normally open contact. But then, let's see. Yeah, so all of those, yeah, I guess all of those are like that. But some of them aren't. So anyway, there's a schematic. We'll go to this one. This is a, I bought this, I already ordered it. This is like a module that does the blinkers, the brake lights, anyway, it's kind of cool. The car had like this old thing, but it's just a pain, and I found this, and it looked like a way easier way to do it, so I bought that, made a schematic for how to hook it up. Let's see. Here's one for the instrument lights. So it has like 4 light bulbs, and that just shows you how those get connected. Here's the actual bulbs themselves. I got to redo this because it's kind of like needs to be redone. But this is going to have a resistor with an epoxy fill and strain relief and wires. I got to do that. The way it is now sucks. Here's what we did for the center gauge wiring. So this car has 3 different gauges, and the center gauge has like a bunch of stuff going on. That's why this is so complicated. And it's diagrams like this that kind of take time, but I had to do this so that I could actually wire the car. This is the kind of stuff that's like confusing. This is the stuff that scares you when you go to wire a car up. So like here, let me go show you on the car. Okay, so that's the gauge we're talking about. Pretty simple. You can see it's got like a battery, an oil, and a headlight LED. There's a, what does that say at the bottom? Tank, that's a fuel. You got mile per hour, which is a cable. I don't have to deal with that. And it's got a backlight. So that's the gauge we're talking about. Okay, so now we're looking at the back of this gauge, and you'll see some labels. I'd put these labels on here, so I didn't have a single idea what any of these wires did. And so what I did was I kind of took a guess and said, well, half the wires are black and all the others have different colors. All these black ones are probably ground. So I just picked one and I hooked it to ground, and then I used my power probe, which I was telling you all about earlier, and I started touching wires. And these are hard to see, but that one says oil. One of them says headlights. This probably says turn indicator. So I basically just used my power probe, the one I showed you earlier. This guy. Yeah, so I used this, and I would basically just hold the button down. I'd ground one side, touch this to the wire, and look in the car. And when you touch one, you'd see like, now you have to get the black and the red wire, so you'd have to get it right. But when you did, if you got both of those, you'd see a light bulb turn on. Yeah. Okay, so yeah, that's how I did it. And then once I knew that light bulb turned on, I'm like, oh, that was the oil light. So I just put a label on it. And now I know which wire, I put a label so I know which one's the oil light, and then I found the battery lamp. And you know, once I got one of these to go, they're all the same. They all have their own black wire for each light, and they all have their own colored wire for the positive. So that figured out those 4. Now the fuel gauge, this has 3 wires. One of them is like positive 12 volts. One of them is ground. And then there's a signal wire that goes to the sending unit, and the other side of the sending unit just goes to ground. So we labeled this as well. Let's see, this is an oil pressure switch. So the way this works, the factory switch, this screws into the engine block. And I checked, right now the engine's off, it has no oil pressure, so the pin conducts to ground. So I just used a voltmeter, and I touched the single wire on the switch and touched it to the engine block, and it beeps. It has continuity, which this is typical of an oil switch. Whenever you have low oil pressure, I actually drew it just so it kind of makes sense. When it has low oil pressure, it conducts. And then when it gets oil pressure, it doesn't conduct. So that's all it is. So we drew that. And then let's see here. Now this car doesn't have a separate bulb for left and a separate bulb for right. Most cars do, but this one has a single bulb. So I take the left and the right hot wire. Whenever it blinks right or it blinks left, I run those 2 diodes to combine the output and run it to 1. But you have to have diodes, otherwise this will like connect the 2 together, and whenever you turn on either blinker, all the lights on the car would be, it'd look like hazard lights instead of blinkers. So this will just be some diodes. I'll show you guys. I actually ordered these. I'll show you how we do that in a future video. But this car needed that so that the indicator will blink for either 1 without messing up the lights for the rest of the car. This is one of the worst schematics we had to do, except for like the ECU. But I thought I'd show you this because this is like when I started the project, this is what I was worried about the most, was like, how do I figure this mess out? Because I didn't know what any of the wires do. So the way I did it was I used that power probe and I used the power supply with the current limiting, the constant current turned down. That way if I shorted something out, nothing bad would happen. And then at that point you just touch stuff until you figure out what does what. So it actually worked out. And I highly recommend, if you guys are trying to wire your own car and you're willing to do all this, like just, get you a little bench supply. They're probably like $100 or something, at least today. I don't know. The one I got probably costs a little more, but it's a BK Precision. But yeah, definitely a great idea. Using the right tools allowed me to figure this out. It took some time, but I did figure it out. And then I labeled the stuff out there so that when it comes to wire the car, I already know which wires do what. I don't have to like beep them out again. Those labels are just temporary, of course. There'll be better ones when it's final wired. Here's the tachometer. So from the factory, I really don't even know, but this isn't the stock tach. But I think it's driven by the alternator, but I'm not doing that. This car has an ECU. So this is kind of cheating, but I'll show you what I did because it's the truth. So the tach has 3 wires, red, black, and blue. Now I was pretty sure that red and black was like positive and negative, and this is going to be signal. And again, I didn't have anything to go off of, so I used my thing and injected like a small line of power. And sure enough, when you power this thing up, it was obvious that it turned on, but it went to 0 RPMs. And I was like, okay, this is probably the tach signal. So here's what I did on that. So I have another piece of equipment called a signal generator. Now I could have used the ECU, but the car's not wired up, so that wouldn't work. So this thing, you can actually tell it to output signals. So I set this up, it's like programmable, and I think these are like maybe $100, but if you're gonna wire your car up, you may need one of these, or it may help at least. So what I did was I programmed this to have 5-volt square wave. So it would just go like tick, 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 tick. And I did the math and said, I want to test like 4,000 RPMs. So if you take an engine, let's do this real quick. 4,000 rotations a minute. So if we divide that by 60, there's 66 rotations in a second. And since it's a 4-cylinder engine, every time the engine turns 1 RPM, it fires 2 cylinders. So times 2. So if I make it fire 133 pulses per second, the tachometer should show 4,000 RPMs. So that's what I did. I just went in there and set the frequency to 133 so that it would do 133 pulses per second. And lo and behold, as soon as I gave it power, the tach did this little like sweep, and then it locked on number 4 for 4,000 RPMs. So that told me a couple things. One, that I got the pulses right, and that it would accept a 5-volt square wave signal, which is great because the ECU, I need to go double check my wiring, but the plan is to use the ECU to do a 5-volt square wave signal, and that's what I wanted to test. And that's how I did the test. There's other ways to do it. You could use an Arduino and program that. But this is how I did it because I have a signal generator. And like I said, they're not that expensive. Here's one for the cigarette lighter plug. We ran number 10 wires to this. We could have got away with less, but I don't like the idea of that. Here's the windshield wipers. This one took a while to figure out. This car had a bunch of custom like weirdness. They didn't have the correct, anyway, long story. The car had the wrong parts. So we ended up Googling and finding a diagram, and then here's the part number. This is the switch that's supposed to be in the car. This is for a 2-speed wiper. So this is the actual motor. I had to find a part number and look it up because this isn't the factory part. This car was like a single-speed 6-volt wiper system from the factory, but it has a 2-speed 12-volt wiper motor. So once I knew that it had something different, and I couldn't follow I wasn't following the stock diagrams anyway, I'm making my own. But once I knew what part it had, I then found the corresponding switch that goes with it. And these diagrams are on the internet, so I just copied it. And then this is the positive wire, which is going to be a red number 16. Looks like I need to put red there. And then that just goes to the fuse called windshield wipers. One thing you'll note on all these schematics, I keep a description. So like the car, the circuit, the date, and the revision. So every page should have that information on it, which allows me to track this in case I change something or make it different in the future. Here's one for the voltmeter, easy, just red and black. Here's the ignition coil. I only showed this one wire because the other wires, we'll get to that later. That's ECU stuff. Volkswagen, let's see, radio. Yeah, this is the radio. So it has like just a Pioneer radio. So I looked up the plug, what the colors are. I even bought a new plug so I don't have to use the janky old one. So we got something for that. Here's our wideband. It's a Innovate LC2. Pretty straightforward. Red, black, and yellow. Here's the ECU. Now this thing had a relay board, which I don't like. They're kind of janky, so we're taking it out and we're just going to do it the old-fashioned way. So we bought, this is a DB37. I bought a 2-foot pigtail harness. It's on the way, and we're just going to like remove all the old stuff and wire this directly in. Now this took some work. I'll tell you the one thing that was kind of tricky on this. This is how they had it hooked up, but when I Google searched it, this shows to be an output for several amps. This shows to be an output for only half an amp, which concerns me because they're not driving a coil driver. They're directly driving the primary of the coil. So I actually took the computer apart to see like maybe they modified the circuitry to handle the high current. Well, it turns out they actually did do that. So this is okay. But that was weird. It's not marked on the computer that modification has been done. So we're going to add that, put a sticker on it or something that says that that mod's been done and that's now a high output on that line. So the rest of this is pretty straightforward. Different sensors. This is the crank. So this has a 10,000 ohm resistor. So they had it kind of rigged into the car. It's kind of janky. We're going to redo it, but it's just captured in the diagram that this goes to the crank sensor. Looks like I forgot to put that. But that's the pull-up. Well, that says crank sensor signal. Oh, that's 5-volt reference. Sorry. That's the crank sensor, but it has a 10K pull-up to the 5-volt ref. That's what it is. 5-volt ref goes to like TPS and some other stuff probably. Anyway, that part of the harness is already done. That's why it's not drawn. But I did want to capture this because it does need a good pull-up. So we'll have to make sure that's like automotive grade. We got our grounds captured. Here's our injectors. Here's our coils. That's our fuel pump output. So yeah, we just kind of follow the diagram for which wires go where. But it did take a while to figure this out. The main thing because of this, that one was tricky. Here's our fuel pump. We're going to put a relay on it. That's it. This is the fuel injectors. So we're actually going to run 4 different wires. It wasn't wired this way before, but it will be when I'm done with it. So all the injectors will be individually controlled. Even though the computer doesn't support sequential, it'll be wired for it. So like in the future, if somebody was to go to like a MS3 instead of MS2, it'll already be wired for sequential. A little bit of thinking ahead. Here's the alternator. I'm waiting on the details of the alternator, but for now I just show that I've got dual red number 8s going out of here. And then this wire is a signal wire to turn it on, but I don't have a diagram. I don't even have the alternator right now. So that one may require a revision. This is air ride, really nothing to go here. It's just making sure it gets power. I'm not touching that otherwise. That's for the USB ports. So this is just to charge your cell phones. Just a nice to have in a car. So this is just a buy part off of Amazon that had good reviews. It'll do like dual 3 amp 5-volt outputs. Here's a cooling fan. This is the oil cooler. So standard stuff. The car has a temperature switch and we're going to use it. So this is just like in the oil hose, and when the oil gets hot, the switch closes, and that'll energize the relay, and that pulls the latch and runs power to the fan to cool the oil down. Pretty straightforward. Starter motor, same thing. Big fat wire from the battery, and then you got another one that goes to the solenoid. Easy stuff. Looks like the last one. That's amplifier. Yeah, so this is just the battery, has a separate wire from everything else. It goes through a giant fuse, and this huge ass wire goes to the front. There's a splitter, and then it switches off, has 2 different wires. One hits the sub, and one hits the amp for the speakers. So yeah, I know that's kind of half an hour to explain how I'm going about this, but this is how I do it. And the cool thing about this is after having all the schematics and having this list, I know how much wire I need, I know what size wires I need, I know where all the wires go. Now this sheet here doesn't capture like one of the schematics we did was the windshield wipers, and it showed a bunch of wires going from like here to there. You know, I didn't capture like the length of all those wires. That really wasn't the point. The point was to just get a ballpark of how much wire I'd need so I know how much to order. But it turns out that you can't buy, or at least the stuff I'm getting, you buy it in spools. So a lot of these spools are like 500 feet anyway. So just making sure it'll be enough. Now, one thing I will mention is the quality of parts. I think I'll do a separate video on that, but that's a big deal. Actually, let's just roll it into this one. This is gonna be a long video. So for this car, this is just like a repair work. So we're just putting it back to automotive standards. So like your common automotive wire is TXL. So TXL wire is like this thin jacket on the wire, and it's pretty durable, and that's what we're gonna use. So we ordered like all these sizes in red and black for TXL wire. We had to spec some relays. Now the relays need to be reliable, so like we used, so here's an example. So this is a relay off of Mauser. This is the one we're gonna use for most stuff. And if you look here, it's 12 volts. It's actually rated for 70 amps, which is quite a lot. This is a pretty durable relay. It's a Panasonic relay. We'll pull up the data sheet for it real quick, and I'll show you why we selected this part. Oh, just kidding. We're going to get a bunch of pop-up. Okay, this might be it. But anyway, this is a data sheet for relays. Now, you can just go off like Amazon and buy a relay, but the reason I get these is they actually have data for these. So you can see here like dielectric, I don't really care about that, but like shock resistance. You know, here's like, these actually have specifications for like how much shock they can take. So like cars hitting potholes and bumps. So there's shock and there's vibe. So here's 10 to 500 hertz. They tell you like, you know, how durable it is. Here's the expected life mechanically and electrically as well. So you can see like how many cycles it'll take, which is pretty cool. And they even show you the test standards and temperatures and all kinds of stuff. So, and there's also stuff in here about the contacts, like contact material. These actually use silver, which is AG is silver. So these have silver contacts so they don't spark and they conduct electricity well. So anyway, this data sheet, this is why I use these relays. These are good quality relays from Panasonic. And it's when you're building a car, you know, knowing how to spec the relay, like, hey, is that relay big enough? Well, we know it is because we actually did the amps for all the circuits. Okay, so one more thing I forgot about. So I showed you guys schematics, but I didn't actually show you all of them. I have another book that has a few more schematics. So this one is kind of like high power distribution. So the car has like dual batteries, and then one of the wires is going to feed into this big part here. This is a bi-part. So this thing has like some giant ass fuses, and then it has like some regular size fuses. Or not even regular size, these are still pretty beefy. These are just like super beefy. And so this guy is what sends power to like power distribution. This is like not fused wires. Well, not fused, not switched. Of course they're fused, it's a fuse block. So I have a diagram for that, and it shows wire sizes and where they go. Like here's the wires to the alternator, here's some wires to the front, that's the key switch, that's a relay that's hot and start, radio, constant power, these go to the air ride. So we have that. Here's, this is actually a pretty important one. So this one is the key switch. So the way I'm wiring this car up, we're not going to run all the high current through the key switch. That might not be, I don't know. There's pros and cons to this. The way this car was wired when I got it, they were running literally everything through the switch, which was for sure overloading it. So now it'll go through like 70 amp relays over here. Here's what I was talking about. See, this contact is normally open, but this one's normally closed. So I had to do a separate, different type of relay for that, but it's the only one that's like that. So yeah, here's our diagram. Looks like we got wire sizes. Might need to add colors to those, but they're mostly red. But yeah, so that's a diagram. Here's our fuse panel. So I'll show you that real quick. This is just a bi-part as well. It's from Blue Sea. It's a 12, I think it's rated for like 150 amps. You just hook like a giant wire here. It comes up and feeds all these different fuses, and then you can pull off of them. And you'll see these are the labels that you saw earlier in all the schematics. Like here's one that says running lights. So if we come over here, this shows from running lights going to the entry of a relay. Well, that's power that comes from the fuse panel, which in this case is a 10 amp fuse. Here's the other one. So this is the one that's hot and run. The other one was run or start. I think that's the last one. Yeah, that's it. So, and another thing you'll note is that these have empty fuse blocks. That one's got 4 spares. This one's only got 2 spares. We used a lot of these. But another cool thing is you want to have some leftover ones if possible. That way, maybe down the road, the owner of the vehicle says, hey, I want to add something, and you don't have to start pairing things to each other. This car, the way it was received, some of the circuits had multiple things on the same fuse. Can't really say much more than that, but let's just say it'll be improved when I get done with it. One of the reasons I wire a car this way is for reliability. You'll see here, like if you look at this diagram, what happens if my wideband controller was to short out? Well, it would blow the fuse, and when it blows the fuse, all the circuits connected to this are going to lose power, which is only the wideband controller. It's not going to take out the ignition, it's not going to take out the injectors. You can guess it may or may not have been wired that way in the past, but by having things on separate circuits, it increases reliability, and it also makes troubleshooting easier, because if I know that the only thing hooked to this fuse is the wideband, I don't have to go check the injectors, the coils, all these other things. I already know, well, it only goes from here to here. So that narrows it down really quick, really fast. Same thing for the rest of this. Pretty much everything is dedicated to dedicated fuses. One of the only exceptions is this piece, which goes to that module I showed you, which it's not shown here, but this module actually has fuses on the module itself. And that's the reason it has a large fuse driving it, because it handles the individual fuses on the module itself. And we just did this because I didn't want to use the 1960s junk, if you ask me, the way it was wired before. So I thought it was better to put a modern piece of electronics for that. So, let's see. I think that's going to wrap this one up. I know it's a longer video, but I wanted to show you guys how I approach wiring a classic car. These can be overwhelming if you don't, I don't wire cars all the time either. Like I've got this diagram. This is a customer car. This is a nice one. This is a diagram. It's all done on a computer. It's all fancy, but that's, that's not your average guy doing that. This is more of like, hey, I just need to get it done and it'd be pretty good, But this works. Like, it seemed overwhelming. It's like, oh, I don't work on Volkswagens. This thing, I learned some stuff on this car. I don't work on Volkswagens like this. So I learned some things. But this is a fair approach. I'm not saying it's the best approach, but it's a fair approach, because this is something you can manage. You basically just remove all the stuff, and then whatever's left that, if you got some gauges or you got some parts, you just start hitting them with power, find out which wire does what, label it so that you know what to connect to, and then you just sit down and make your schematics. You do like the book we talked about, like this. You just make your list, your headlights, your taillights, your running lights. You just go down the list and list all the circuits that your car has, and you just do it one piece at a time, and one schematic at a time. And you keep doing that, and eventually you've got to, you'll have everything figured out. It takes time, but what's nice about doing it this way is it's less stress. You're planning stuff, so you end up with better parts. I expect all of this will work. I don't think I'll have to redo anything unless, maybe I'll check my schematics, make sure I didn't miss something, but that's the whole point of this. Now I can just wire the car up and it should work. And if there ever is a problem, I have documentation on how it's wired, which of course that's going to go to the customer, but still they'll have documentation if there's ever a problem in the future. If someone needs to know, hey, how is this hooked up? For troubleshooting or upgrades or repair, whatever the case, they'll have schematics for everything. So it's a lot more manageable, and that's what I wanted to show you guys. A lot of people think that wiring is just a beyond reproach, something that somebody else has to do it. I can't do it. This is something you can do. I think in another video I'll show you the practical how to go about hooking wires up and crimping things and stuff like that. We'll do a separate video on that because this one's gone on forever, but that's a big deal too. Fact is, you are gonna have to spend some money to buy a few tools so that you can crimp wires properly, you can insulate them properly. You don't want to do all this effort and then have low quality connections. Even if you've got good wire and even if you've got schematics, and you don't want to have bad connections either. And you want to plan out where your connections are made and things like that. So we'll cover some of that in another video. But that is another important piece. But this is the one that oftentimes you're not going to hear about. And this is a big key to success. Not everybody knows everything and can just remember all this stuff. This is how you do it. You actually document stuff and create schematics. Anyway, hope you guys have enjoyed this. Y'all let me know in the comments if you like this kind of stuff. But yeah, till next time, y'all take it easy.